Hello, so I want to talk about how to create a custom component in Diptrace. So start off with finding the datasheet for the component you want to create. So here it is in DigiKey. Mouser would have the same sort of stuff. You want to look for the datasheet. And then on the datasheet, you should see some sort of picture with dimensions. So here the dimensions are going to be different for different ones, different versions of this transformer, but it's a transformer that we are going to do. And you could start with the schematic image or the circuit board layout. I'm going to start with the circuit board pattern. So in my circuit board program, I'm going to go to Tools and Pattern Editor. Open the Pattern Editor. And then I'm just going to go ahead and create a new one. So say Pattern, Add New to my library. And the way I title them, I'm going to do T for Transformer. It just helps me organize them. And then this is a signal transformer. And then going back and forth, I want to set the basic layout. So I'm going to start with the overall size of the whole transformer, which is going to be W and L. So the one we are using is they go by VA size. This is a 20 VA. So 20 VA is right here. So I want, again, L and W. So L is 57.2 and W is 47.6. So those are the dimensions I want. So I'm going to create an outline. And I want it to be 57. And you can make this really specific if you want, but if you double click on it, it's a little bit easier after you've drawn it already. So I want, again, 57.2 is the width. So width, let's do width. So we actually want width first, which is W 47.6. So we'll make this 47.6. And then the length was 57.2. And then I like to have the anchor point being in the center, and I'm going to go ahead and put it right on the center, right at 0. There we go. That's what my transform looks like. Now this will put the mounting connections to the circuit board here and here. If you want to be top and bottom, you could do that. Just flip the length and width. So now let's look at how many connections we have. So here's the schematic symbol. So there are only 6 connections. However, there are 8 holes. I'm going to zoom in on this a bit. And we need to have all those holes because those are pins coming out of the transformer, even if they're not being used. You need to have space for them, a hole for them. And also you want to have a mounting hole because it's going to help hold the whole thing in place. So there are 4 of those on each side. And there's a space in the middle of them. And also the other thing we're going to want to know is how big the pins are. So square bin dimension right there. So 0.91 millimeters. So that's the hole size we want. So I'm going to set that first. And that will be my standard pin properties. If all your pins are going to be the same, you can use this. If you're going to have all of them different, then you can set them all separately. So through hole, we want ellipse. So this is the outline, the outside of it, the pad where you actually solder to, and then here's the hole. So we want a hole to be 0.99 is the size of the actual pin, so we want a bit bigger than that. 1.1 sounds really good to me. And that looks good. And then 3, I'm going to go make it a little bit bigger on the outside than that. And then I want 4 connections on this side, 4 on this. I could take each one separately and put it in. I'm just going to roughly put them in place and then I'll move them. The other thing you could do is you can do a row of holes. And then you set the spacing of those. But for something this small and probably most of what you do, that won't be actually the easier way. So I'm just going to put these in place. And up here is your grid. On all these programs you have this. So I'm going to go ahead and set this to 2.54, which is a little bit more typical. And it's going to number them for me, but I'll probably change that numbering. So I'm going to take a little less space for this so I can see my dimensions on my data sheet as well at the same time. And when I do this, I'm using 2 screens. It's just too hard to record 2 screens and have you see what's going on. So let's see if I can get this to work. I think so. I'll get that way. Okay. So in the middle here, there are two things we want to think about. So M is the distance between the 2 rows of pins. So I'm going to go ahead and start with that. So I want each row to be that. So M is, again, for 20 VA, M is 38.1. Since these are centered, I want each of these to be half of that, which is going to be 15, 16, 17.25. So I click on each of these, and I want it to be minus 17.5 for the X dimension. 0.25? No. And each of these will be that. And the quicker way would be to cut and paste. So I'm going to do that on this side. So just type it in and copy that. Oops. Hit the wrong button. So now they're left to right, correct, on our x-axis. Now we'll do the other axis. And in the middle, we have a B dimension. So these 2 middle ones are slightly farther apart than the outside ones are. So that B dimension is 10.2. That means these will be 10.2. And these are going to be 10.2 as well, but negative. And that's the nice thing about just roughly placing them where they go, is that it helps you remember if they should be positive or negative, because you're not going to change that. And then between those 2 pins, the dimension is A. So that's 10.2 again. Okay, so that's not as difficult as I thought it would be. Yeah, some of them are different, the A and B dimensions, but the size we have, the A and B dimensions are the same. So this drawing is a little deceptive for this particular size. So if this is 10.2, this is going to be 20.4. Oh, wait, I did that wrong. So if this is 10.2 between A and B, then each of these needs to be 5.1. And then minus 5.1. There we go. And then this is going to be a 5.1 plus 10.2 for this next one. So 15.3, right? So that's what we have. And then we're going to make sure we number them all. So we need to make sure we know how this is laid out. So this picture here is most likely from the bottom, although we need to double check that that is true with the actual physical part once we get it. So pin 1 is actually over here. So it should be 1, 3, 4, 6, and then 7, 9, 10, 12. So this is 1, 1, 3, and notice they're not consecutive. Usually what that means is they're laying it out on a pattern and they're skipping some of the pins in the pattern. And then we start back at the bottom with 7, 9, and these numbers are important because the data sheet is also going to show us what connections go to what pin. If we change the pin numbering, that won't work out well. Now, one of the common things to do is to mark pin 1, so it's really clearly noted. So we're going to do that. We're going to click on pin 1, go to type and dimensions. We're not going to use the standard pad properties. Instead, we're going to make this rectangular. There we go. And that's the common thing to do, is to make pin 1 rectangular. So you know, looking visually at the schematic or at the circuit board symbol, that this is pin 1. Okay, so that's where we start. So that's our circuit board pattern all laid out and ready to go. Make sure we save. Now we want to draw a schematic symbol and connect the schematic symbol and this pattern together. So I'm going to go to component editor and create a component. Now the easiest thing to do is to go to an existing one. So we'll find a transformer, because it already has all these nice inductors drawn for you. We could see if we can find one that has exactly what we want, because we want, looking at the schematic symbol, or excuse me, the data sheet, we want 2 primaries and a single secondary. So we'll see if we got any that look like that. And again, it's just all about how much time you want to take. Oh, there we go. So here's one. This is exactly what I want it to be. As far as the schematic symbol goes. The only addition here is that this particular transformer, this is actually an input transformer, an audio input transformer. It has the metal can actually connected, the case connected to another pin. So we'll get rid of that. So I'm going to go ahead and duplicate this. So right click on it, duplicate my component, click on that, make sure I'm clicking on that, not editing the original. I've done that enough times. And we're going to go power trans. And this is, the company is called Signal that makes it, which is, I don't like, because I would call this a signal transformer, naming it based on the company that makes it, but it's not a signal transformer, it's a power transformer, because signal would mean a signal going through it. But that's how it goes. Now back to our data sheet. 1, 3, 4, 6 are our pins over here. So rename these. This needs to be pin 1, and it is primary to negative. That's fine. So that's the primary, 1 positive, 1 negative, 2 positive, 2 negative, all labeled P for primary. So that was 1, 3, 4, 6. This will be 3. This will be 4. This will be 6. And then the other side is 7 and 12. 7 down here like it is, and 12 up here. There we go. And now we're going to connect a pattern to it. So click on patterns, go to user patterns, which is where my library is. Click on my library. And then, so they created a new one. It's going to be at the very bottom right now. And that is because I haven't organized it yet. But if I go back to my pattern program and go to library tools, I can sort patterns, and that'll alphabetize them. Now it's no longer at the bottom. And I'll find it here to switch back to it. So find my T's. Oh, it's still there. So sometimes it doesn't refresh right away, and maybe I didn't save. That's why. Save, and now it'll fix it. And there it is, where I want it to be. And if I click on these, I can see where they connect. Those two don't connect anywhere. Say OK. And save that. Now this library is saved with that transformer. Now I can go to my schematic program, and I will have that in there. Look for T's. There it is, power trans signal. Pull it over. There it is. Right click on it, and I can see attach pattern. There's the pattern I want. So that's all like I want it to be. The only extra thing you might want to do, which I think is really useful, go back to the pattern. And this is optional, certainly. Go to here, and we want to set the 3D model. Now, 3D models, it's a separate file you can download from Diptrace and install. But if I look at that and go to all models, I should be able to find a transformer that'll be close to what I want. Usually under general. No, it's not general, is it? A lot of patterns you can find online, and I'll do that most of the time now. Okay, VR. Under this VRML is where I typically find a lot of things, just generic ones here. Let's see if they have transformers. Let's see. I know they have some here somewhere, generic ones. But I'm not seeing them right now. So the other option, if you can't find them there, is to go look for an actual 3D model of this whatever component you got. And I've had luck with that in a lot of cases. So if we go back to DigiKey, we can see if they have one. Mouser has a spot for it. DigiKey does as well. So here's CAD model that might work for us. It often will say that there's a 3D model. There's a Snap EDA model, which actually should give us most of what we just built. A lot of times you can find a model that will work. Yeah, so this actually gave us exactly what we needed. We could have downloaded this, but I wanted to show you how to make one. No, there's something about the 3D model, but okay, it says 3D model. Oh, here it is, 3D model. Found a 3D model, so download this 3D model. Let's see what it looks like. So good, there's a real nice 3D model of this. So we'll download this. Generate CAD. And it might ask us what kind we want. So I'm going to sign up for this. I haven't used this particular company yet, so I'm going to pause the video while I do this. Okay, so I got all registered. Generate CAD. And then The step format is what typically works best for this program. So find it. Here we go. Step. So good. Create that. There we go. We'll download that. And then I have a folder I put all that in. It's just full of my 3D files. Okay. I'm going to move it to where I want it. There's my 3D models. This one in. Unzip it. And then it's sitting there. So now go back to my program and click here on these 3 dots. I'll get rid of this. That'll let you load wherever. And then here's my 3D model folder, and we'll find that. There it is. Loading it. And then there it's sitting. Now I have to rotate it and things. So we'll start by rotating, and I'll get this wrong most likely. I think I want to rotate X 90 degrees. And I got that wrong. Well, I rotated what I wanted to, just not quite right. So I'll do 270. That's right. Now I have to move it above on the Z-axis. So I'll shift it up on the Z-axis 40. Not quite enough, so 45. Okay, we'll do 50. There we go. That sets it about the right position. I need to rotate again to get it right. So I'm going to rotate, I think, Y 90 degrees. Nope, not that. Again, I always get this wrong. There we go. So that's rotated correctly now. And I need to shift over X some. Too much. So that's pretty close. And there's no, sometimes there'll be an indication of pin 1 on the actual 3D model. There isn't, so that's okay. So I'm really close. And from the top, I just can't see where the pins are. So that's why I flip it over. And sometimes turning it a little bit like this is the easiest way to see it. So I got to rotate. I got to move X a little bit more. Shift X 35. That's too much. 32. That's pretty close. Now I'm going to shift Y a little bit. Other direction. Minus 10. That's too far. It's 5. Okay, so that's really close. Shift 4. That's pretty close. And then that's pretty close. Notice the pins are a different dimension apart, which is makes me wonder if I have messed something up. But so I want to double check that dimension on my part. So let's go back to our data sheet. So that M dimension is how far apart my pins are. Oh no, C is the dimension. So I found M, but I actually want C. And C is 37.1. And I did 38.1. So, and this is one of the nice things, if you get a 3D model that's really accurate, it can help you catch problems. Now, I would want to hold the actual component over a piece of paper printed out before I order circuit boards. But so C, again, 37.1. That's what I want this to be. And that, so 7.1, 18.55. Here. Oops. What did I do here? I didn't get that one. Oh, it's because there's a... There we go. Get rid of that negative. Now, 3D models aren't, excuse me, aren't always going to be right. So that's why I definitely checked the data sheet and saw that I had a problem, but it was nice that it caught that for me. So now I'll go to this, look and see. And again, I want to shift X over a little bit more. And there, they all fit nice and pretty. They almost look a little bit off, but I think it's close enough for me. Maybe do 34. There we go. That looks pretty good to me. And you could drop it down a little bit on the Z-axis if you wanted to, but I usually like to have it sit up a little bit so I can see underneath it. Okay, and save that. So now when I go to one of the other programs, so these changes cascade, and you can update the schematic symbol to this, but for this you just have to check the pattern again and okay it, and then that'll do everything else you need. You can do pattern. No, that's about all we can do from here. Save that. Then in the schematic program, I can just click on it and I say update from library. And the options there are selected parts, just the one I just did, selected components. So that's if I have this component multiple times in my circuit, it would do it. Similar name, that's anything that uses the same pattern. So if I have multiple of these, I will do similar name components. Or selected parts, you can select multiple ones. And then you can always check if you've changed anything. You can look at the attached pattern. And oftentimes, even if I change little things like pin numbering, I might change something on the symbol just visually, so it's easy to tell that it's the new one I'm looking at. Save that. Oh, actually, I don't need to save this. So now, let's convert this to a circuit board. So I'll save this. And I'm just going to put it on my desktop so I can get rid of it. And then I'm going to create a circuit board. Here's my outlet layout the outside. And I'm going to add that component. Actually, I'm going to just link it to that file I just created. Okay, and then update it. And there it comes. Put this on, and then if I go to 3D model, it'll render this. And then there's my transformer sitting on my board. And if I were to add, see if I remember what all I have models for. I know. Pretty sure there's a model for this. I think most of my transistors have models. Anything else that's modeled? I know I have. I'm sure this has a model. No, that one doesn't. The horizontal ones do. There we go. No, those have models. So then, just to give you an idea of what this might look like. And sometimes it disappears, but if you just click on the file. So there we go. There's my transistor and my XLR. And I think the transistor was from Diptrace library. The resistor, definitely, I didn't like their resistors. This one I liked. It just looks more natural. A lot of these I find from 3D content libraries that are just people add to. And you can export that if you want, and then import it into a 3D design program and build like a case around it or something. Ask me if you have any questions.